There's several features that characterize sine and cosine graphs, and we're no longer just talking about the original functions sine of x and cosine of x. We're talking about all the things we can do to those graphs. So the general name for a shape that looks like a sine or cosine graph is a sinusoidal curve. Not really expecting you to know that term. I'm just saying, by way of explanation, we're going to be doing lots of modifications of sine graphs and cosine graphs, and we want to be able to talk about how each of these components, a, b, and c, changes what the graph looks like. So the first feature we're going to discuss is what's called amplitude. So the amplitude of any curve is the distance from its center point to the top or from the center point to the bottom, and it's going to be the same in both cases for our sinusoidal curves. So the way we can find that distance is by just using the absolute value of this number a that's out in front. The reason for that, if you think back to transformations of functions, is that we're just multiplying the whole function by that number. So normally, the amplitude is going to be 1, because the graph goes from -1 to 1. However, if we multiply the whole thing by some number a, it's going to get a times as tall, which makes sense then that the amplitude, in other words, the distance from the center to the extremes, is going to be absolute value of a. Okay, so the amplitude of this function, 2 sine x, well, because I multiplied by 2, a is 2. So the absolute value of a, still 2. So the amplitude of that function is 2. So now if I wanted to graph 2 sine x, the way I would do that is starting by graphing the function sine of x. So let's do that first. Okay, so we already studied earlier what that looks like, right? We played around with an activity, we've seen it here. So let's just basically sketch that out first. Okay, so I'm going to be careful to label my axes so I know exactly what's going on. And it's going from -1 to 1. Alright, so here's a quick sketch of that. Up, down, down, up. Okay, and then it's going to repeat itself. Okay, so up, down, down, up. As a general rule of thumb, anytime you sketch a sine or cosine graph, or really any trig function in this course, I want you to sketch at least 2 complete periods of it. So one period went from 0 to 2 pi, the next one went from 2 pi to 4 pi. If you'd preferred, you could have gone backwards too. Okay, so now I'm adding on a third period of this function. Is the graph perfect? No, not at all, but it definitely shows what's going on, where it's got that midpoint, that high point. Okay, it might help you to go ahead and just actually put in those important points on the graph, just so you can pinpoint where everything happens. Alright, but this graph right here in black was sine of x. What I'm really interested in is 2 sine of x. So in red, I'm going to do 2 sine of x. And all that does is vertically stretch the whole thing by a factor of 2, which also is going to make sure that we end up with an amplitude of 2. Okay, so instead of just going up to 1, it's going to go up to 2. And then it's going to come down, go down to -2. Okay, so you can see it's the same shape, it's just twice as tall, and it goes out twice as far. Okay, so that's the relationship between these two graphs. This one is just multiplied by 2, so it's twice as tall. Or it goes twice as low is another way of talking about that too. Okay, so it goes on forever, but so long as we've got at least 2 periods of that graph sketched, that shows what's going on in that function.